Okay, good morning, guys. I just want to talk to you today about balancing chemical equations, okay, which is something that as you go through school in chemistry in year 9, 10, 11, you're going to get to do a lot of, okay, but I want us to have a bit of a basic understanding of this at the moment. So we're going to start off looking at the reaction that's on the screen right now, which is the reaction, let me just move this a little, which is the reaction between methane and oxygen. It's what we call burning or combustion. Okay, so in this reaction, we've got methane, which is the gas that comes out of the tap, CH4, a carbon, which is the black atom here, joined to 4 hydrogens. Okay, remember, hydrogen only bonds to one thing because it's in group 1. Carbon's in group 4, so it bonds to 4 things. So it forms a CH4 structure. Now that's going to react with oxygen. Remember, oxygen comes as a diatomic molecule. It's not just a single oxygen atom, it's oxygen bonded to itself. Oxygen, okay, wants to bond to 2 things, so it actually forms a double bond here. Even though you can't see it, you've got 2 bonds between each of the oxygen. And we know from a week or so ago that whenever we burn any fuel, like hydrocarbon, okay, and make it react with oxygen, okay, that the products of complete combustion are carbon dioxide and water. So we're going to get carbon joined to 2 oxygens. Okay, these are actually double bonds as well. So each carbon is joined with 2 bonds to the oxygens. And we get water, which is H2O, 2 H's joined to an O. Now, hopefully you're already happy with that. You could have told me that a fuel reacts with oxygen to give carbon dioxide and water. But there's a bit of a problem with this reaction on the board and the equation I've written. I'm just going to let you have a look at it and see if you can figure it out for yourself. So pause the video here and see if you can work out what's wrong with this equation. But hopefully you've spotted that the big issue we've got here is that the reactants and the products don't add up, okay? Because we started with 1 carbon atom and we've got 1 carbon atom at the end. That's fine, no problem. But we had 4 hydrogen atoms to begin with, and now we've only got 2. So it's like we've destroyed 2 hydrogen atoms. And in terms of oxygen, we started with 2, and now we've got 3. So it's like we've created an oxygen atom. So we've destroyed 2 hydrogen atoms and created an oxygen atom. Well, that's not allowed in chemistry. We've got something called the conservation of mass, which says that basically however many atoms you have before the reaction starts, they're still going to be there afterwards. So this is not okay. So we need to come up with a way of balancing this, okay? And what we are not allowed to do is change the formula that are up there. So I can't change, for example, CH4 into CH2. I can't just say, it's not going to be called CH4 anymore, it's going to be CH2. I'm going to take 2 hydrogens out, and then I've solved the hydrogen problem. Methane is CH4, so we can't muck around with that. We can't muck around with the O2. We can't turn it into an O, okay, or the CO2 or the H2O. Those formula are set in stone. What we can do is put numbers in front of them, so that instead of, for example, 1 CH4 molecule, I have 2 of them, or instead of 1 water molecule at the end, I have 3 of them. Okay, and actually, the way to balance this equation, okay, is that we need to have different numbers of each of the molecules involved. Okay, so we actually only have 1 methane molecule, okay, and it should react with 2 oxygens. Notice I haven't changed O2 into O4. I've just said that I'm going to have 2 of these molecules, and they'll react together to give me CO2, a single molecule of CO2, and 2 water molecules. Okay. Now, if I look at this before and after, okay, before I've got 1 carbon, which is a black one in the middle, after I've got 1 carbon. Well, that was sorted beforehand anyway. When I look at the hydrogen, I've got 4 hydrogens before, and now look, 1, 2, 3, 4 hydrogens afterwards, because I've got 2 lots of 2. So the 2 in front of the water, 2 in front of the H2O here, means I've got 2 lots of the whole of H2O. Not just 2 lots of H, I've got 2 lots of H2O. That means there's 4 hydrogens and 2 oxygen. Have a look at the diagram up here to see what I mean. There are now 4 hydrogens and 2 oxygens. I've got 2 lots. A number in front means 2 of the whole lot of this molecule. Okay, so we've got 4 hydrogens to begin with and 4 oxygens. Sorry, and 4 hydrogens to end with, and we've got 4 oxygens to begin with, and 2 oxygens in CO2 and 2 oxygens now in the 2 water molecules. So we've balanced that equation. Now, what you're going to be doing today is all going to be about balancing equations. And there's two different tasks you're going to work on. The first one is going to be using a simulation which is linked on Google Classroom. Okay, so what I'm going to do, I'm just going to close down this. Where is it? Here we go. Okay, so I'm going to show you how to use the simulation, and we're going to use it. If you look at the bottom of the screen, there's either an introduction or a game. Now, I'm going to use the introduction to show you how to use this, and then you're going to come along and you're going to use the game. You're going to start on level 1 and you're going to solve all the problems, then level 2, solve all the problems, then level 3. Now, this is going to be the practice ready for the second task on Google Classroom, which is going to be a sheet where you're going to be filling in balanced equations. Okay, so that's the one that I'm going to be marking. So this one I'm not marking, but you need to do it to get yourself good enough to be able to do the piece of work that I'm going to be checking. So we've got 3 different reactions that are going to go on here. Okay, so I'm just trying to get something off my screen. Bear with me 1 minute. Now we've got 3 reactions here. We've got making ammonia, separating water, and combusting methane. Combusting methane is actually the one we've just done on the screen now. Okay, so that one should be simple. Now, this reaction involves nitrogen, N2, which is another diatomic gas, reacting with hydrogen, H2, another diatomic gas. They come as pairs, giving ammonia. Ammonia is NH3. Okay, now notice, the simulation will not let me change the formula of N2, H2, or NH3. Okay, the only thing I can do is muck around with how many there are. Okay, now at the top you see it says tools, and at the moment I've selected none. Well, I can select a couple of things that might help me to kind of do this, like for example, weighing scales here. Okay, now the weighing scales is just going to put all the different elements involved and tell me how many I've got before and how many I've got after. Okay, there is also a kind of bar chart you could choose, which is going to tell you how many of each you've got. At the moment, there's none of each, so it doesn't make any difference. But if you want to choose either of those, they might be good for helping you. The first thing I would always do is put one of each molecule involved, okay, and see if that works. So will one nitrogen molecule react with one hydrogen molecule to give one ammonia molecule? Well, no. And you can see why it doesn't, because the nitrogen before is greater than the nitrogen after, and the hydrogen before is less than the hydrogen after. So the scales need to be balanced. So I would think, well, I need to have more nitrogen after, because at the moment I've got 2 before and 1 after. So let's knock the after up. Right, we've sorted out the nitrogen problem. Nitrogen is now balanced, 2 before, 2 after. But you can see we've made the hydrogen problem even worse. I've got 2 before and 6 after. So I need to add some more before. So let's add another one before. Right, now I'm getting closer. And I add a third, and now I've got a balanced chemical equation. So the key thing is what I've got left at the bottom here. One nitrogen molecule will react with 3 hydrogen molecules to give 2 ammonia molecules. Okay, let's do it with the separating water. So separating water, water is H2O, okay, and we are going to turn that H2O into hydrogen and oxygen. So same as last time, I'm going to start with 1 of everything. And remember, all I can change are the numbers in front. Okay, so 1 of everything, does that work? Okay, no. It's okay for the hydrogen because we've got 2 hydrogen before and 2 afterwards, but it's not okay for the oxygen. We've got 2 afterwards and only 1 before. So let's add an extra oxygen before. Well, I can only add an extra oxygen before by putting an extra water molecule in. So I've knocked that up. So my oxygen is now sorted, but I've unbalanced the hydrogen. So I need twice as much hydrogen afterwards. I've got 2 at the moment, but I need to change that to 4. So here's my 2 hydrogens in each molecule. I knock that up to 4, and now I've got a balanced equation. Okay, same amount of hydrogens before as after, same amount of oxygens. And let's do the final one, combustion and methane, burning. Sorry, my computer's very slow at the moment. Every time I click something, it takes a while for it to respond. So this time we've got 3 different elements in it. We've got carbon, hydrogen, and oxygen. So same as before, let's add 1 of each of them to here. Now, carbon is balanced. We've got 1 carbon before, 1 carbon after. Hydrogen too many to begin with compared to afterwards, and oxygen too many afterwards. So let's do the hydrogen first. So we need 2 more hydrogens afterwards. Well, there's 2 hydrogens in water, so if I add 1 more water molecule, okay, that's balanced my hydrogen, okay? But now I need 2 more oxygens to begin with because I've got 4 afterwards and I've got 2 at the start. Well, we can do that quite easily by clicking on the oxygen here, and we've got a balanced equation, okay? So if you want to start off with, you can have a go for the introduction, just doing what I've done. But what I want you to do then is to press on the game, you click on each level, and you've got something very similar to what I've just shown you there when eventually it comes up, and you're going to be balancing each equation. Okay, so remember, like I did, start off by trying 1 of each, and once you've done that, it's a little bit of trial and error. Let's add a bit on the reactants, or let's add a bit on the products until we get it balanced. So have a play around, do all of the kind of 3 levels of the game here, and then if you can answer the questions to the sheet, okay, if you do it on a piece of paper, take a photograph, and can I ask that when you upload it to Google Classroom, you do it as a single document, so I haven't got to go through lots of photographs. You can get it all onto one clear photograph that I can just check, okay? But any questions, then please send me an email or a message through Google Classroom. Hope it all goes well.